Well, hey there. We got a few more minutes till you guys get to experience Genesis, so gonna need something for you guys to do. Hey, Ralph.
Yo. The vision of this film, what are you hoping to accomplish?
We're trying to show that the Bible is true, but also the science to back it up.
If we're going to have a debate about science, can you please just be honest about it?
Paulogia presents The Science of Genesis, Paradise Lost. Part 8, Dating Troubles. If you're new to the series, click on the eye in the top corner to watch from the beginning.
Well, a lot of people think the biblical chronology couldn't be true because the Bible says the earth is 6,000 years old.
You may recall from part 2 that the 6,000-year age belief doesn't come directly from any passage of scripture, but rather from James Ussher and others who endeavored to add up all the given ages in all the chronologies in the Bible. In other words, this 6,000-year age comes from a particular interpretation of the Bible, not something the book says explicitly. Even if the Bible is a divinely inspired work, I think everyone would agree that human interpretations are subject to human error.
That's very, very different than saying the Earth is 4.5 billion years old.
That is very different.
How do we know it's 4.5 billion years? Because it's only ever stated. It's 4.5 billion years, we know that. Well, how do you know that? Radioactive dating.
What was that voice for? I thought the point of this movie was to present scientific evidence for six-day creation. And now you've got a PhD in microbiology making an argument from funny voices? Let's hear that again.
How do we know it's 4.5 billion years? Because it's only ever stated. It's 4.5 billion years, we know that. Well, how do you know that? Radioactive dating.
And now let's hear the same thing, but from another perspective.
How do we know it's 6,000 years old? It's only ever stated.
6,000 years, we know that. Well, how do we know that? Biblical genealogies.
Was that helpful? Did it add anything to the discussion? But we've already seen this poisoning the well with inflection from Charles, and now we're getting it from Andrew. Is this film legitimately trying to make an argument, or merely providing affirmation to those who already believed before the film started? Note that Drew's 6,000-year version is much more accurate. Even if you believe it, it's the 6,000-year estimate for the Earth that is literally only ever stated. The only place you can find that claim is in the pages of the Bible. Taking all of creation science at face value, you might arrive at a less than 10,000-year estimate, but specifically 6,000 is quite literally only ever stated. As for the 4.3 billion year age of the Earth, accept the conclusion or not, but recognize that scientists from multiple disciplines came to this conclusion based on thousands of experiments, with dozens of revisions over centuries of acquiring evidence. No one answers radiometric dating because it was merely stated in some authoritative book. It was discovered. Science has no authorities, no scriptures.
You know, a lot of people think that carbon dating proves that the rocks are millions of years old.
It does seem to be common that people mix up the phrases carbon dating and radiometric dating. Radiometric dating is a broad term to describe a number of different dating methods, where carbon dating is specifically one of those methods. Just like painting might be considered a broad term, but watercolor paints are a specific type of paint with a specific purpose. It sounds like he's about to clear up the misunderstanding, but why is the graphic on the screen further confusing the point by showing the general phrase radiometric dating, while at the same time the speaker is talking about the specific carbon dating? Does the movie want to clear up the confusion between the two, or does it want to further confuse them in the audience mind?
Carbon dating is never used to date the rocks. It's only used to date former living things.
This is correct. The film will talk about useful timeframes for carbon-14 dating soon enough, but the main reason that carbon dating is never used to date the rocks is that carbon dating requires that the thing being studied is biological in origin and was once alive. Things like hides, cloth, wood, or plant fibers. When cosmic rays enter the Earth's atmosphere, they collide with atoms which create energetic neutrons, which in turn collide with nitrogen atoms. When this happens, a nitrogen-14, 7 protons, 7 neutrons, turns into a carbon-14 atom, 6 protons, 8 neutrons, and a hydrogen atom, 1 proton, 0 neutrons. This carbon-14 is absorbed by plants. As animals eat plants, they take in carbon-14 as well. The number of carbon-14 atoms in the air is tiny compared to the number of regular carbon-12 atoms. And while carbon-14 atoms are always decaying, they're being replaced by new carbon-14 atoms at a constant rate. As such, the ratio of carbon-12 to carbon-14 at any given time is constant, be it in the air or in a living plant or animal. As soon as a living organism dies, it stops taking in new carbon-14. The ratio of carbon-12 to carbon-14 at the moment of death is the very same as any other living thing, but the carbon-14 continues to decay at a constant rate and is not replaced. As such, the ratio of carbon-12 to carbon-14 in a sample can tell us how long it's been since that material stopped being alive. Since rocks were never alive, the carbon dating method would never work on rocks. Instead, we measure the age of the rocks with other radiometric dating methods like uranium, lead, potassium, argon, rubidium, strontium, uranium, thorium, and others.
No evolutionist uses carbon-14 because even if it worked the way they thought it did, it can only go out to 110,000 years max, even using the new accelerator mass spectrometer method.
The limitations of carbon dating have little to do with technology and everything to do with physics.
The half-life of carbon-14 is so short, only 5,730 years. You should not find any carbon-14 in anything older than 100,000 years should have even one atom we could detect.
Radioactive decay rates are expressed in terms of a half-life, the length of time that it takes for half of a sample to change form. For carbon-14, it takes 5,700 years for half of the parent, carbon-14, to change to the daughter, carbon-12. It takes another 5,700 years for the next half to change, 5,700 years for the next half, and so on. After 100,000 years, only one 262,144th of the original carbon-14 isotopes would remain in the sample. Certainly a number too small with which to infer an accurate count. 50,000 years is the standard estimate for the maximum age for which carbon dating can be useful.
The fact that people are routinely finding significant levels of C14 in all these different fossils indicates something wrong with dating methods.
All right, well, routinely finding significant levels of C14 in all these different fossils sounds like it should be very easy. I was unable to locate any peer-reviewed scientific literature to confirm these routine results, so I turned to creation literature. The primary related article at Answers in Genesis, called Carbon-14 in Fossils and Diamonds, from 2011 by AIG staff geologist Andrew Snelling, seemed like a promising lead. The section called Radiocarbon in Fossils Confirmed didn't mention carbon-14 finds in dinosaur fossils. I just like dinosaurs and it would have made the subsequent research more fun, but rather points to a few instances of fossilized wood and one of ammonite shells. With no specific finds detailed, I took to the 7 footnotes to investigate further, only to find that all 7 references are the research of Andrew Snelling, the very same author of this article. Only a single source like this doesn't feel like routine finds. All the citations were from creation journals rather than peer-reviewed publications. The most recent and most interesting was this one from 2008, and included a summary of the history of carbon-14 in fossil finds, starting with a frequently cited 1970 Creation Research Society article by Robert Whitelaw. Snelling boasts that Whitelaw speaks of 15,000 samples that contained radiocarbon, but fails to mention that these 15,000 represented every single published carbon dating result in the then 20 years since the method's invention, explicitly including life both recent and ancient. Of these thousands, Whitelaw identified just 250 that he considered to be in the category of fossils, extinct fauna, and prehistoric man. And even this included many non-ancient sounding things like sloth dung, bison bone, and penguin bone. But by Snelling's own admission, the scientific community never took these anomalies seriously because these measurements were obtained using the beta decay counting technique. Beta decay counting technique from the pioneer days of the method that, among other issues, had trouble distinguishing between carbon-14 atoms and background cosmic rays. The accelerator mass spectrometer method, developed in the early 1980s, took over from beta decay counting. In Creation magazine Origins in 2001, Paul Geim identified 70 instances from 1984 to 1998 where carbon found was higher than carbon expected, in samples primarily marble, graphite, coal, and wood, not the materials people usually think of when they hear the word fossil. Geim allowed that contamination was a possible cause, and Snelling concedes that contamination during sample preparation was a genuine problem in this era. Indeed, during this time, Thomas Stafford and team studied such sources of error and found that the majority of bones that are used for radiocarbon dating and stable isotope analysis have undergone moderate to severe diagenesis and are often contaminated with substantial amounts of humates and other foreign organic matter. Since then, new methods of identifying and reducing contamination have been developed. Snelling provides no modern examples of locating radiocarbon in fossils, instead focusing on coal and diamonds, with the exception of his ammonite shell. Unfortunately, one of the well-known limitations of carbon-14 dating is usage on marine life. As this 2010 paper reminds its readers, marine shell carbonates are often considered problematic for radiocarbon dating. Problems most often identified include the reservoir effect, among numerous others. These marine shell pitfalls may well have been considered by Snelling on this ammonite find, but it is curious that his 22-page paper doesn't even contain the phrase reservoir effect in order to rule out the most commonly known complication. It's possible that there are genuine finds of original carbon-14 in fossils. However, if Terry's claim that significant levels of C14 are routinely found in fossils is true, and not just some repeated mantra, I'm curious as to why the large creation organizations like Answers in Genesis and Institute for Creation Research don't even have a few modern examples to present.
The half-life, the decay rate of carbon-14 is very short, so it's never used to date the rocks. It's the other methods, uranium changing into lead, potassium into argon, rubidium into strontium, and they have really long half-lives.
If you knew that, why did the movie spend time further confusing people about carbon-14?
All of those, including carbon-14, depend on four basic assumptions. One, you somehow have to be able to estimate the original amount of the parent isotope.
Wherever possible, modern radiometric dating is performed using the isochron method, specifically designed to remove any assumptions about the initial quantities of the parent and daughter isotopes. Like basic radiometric dating, the ratio of parent isotope to daughter isotope is measured. In addition, with the isochron method, multiple samples of minerals from the same pool of materials are taken. Rocks with a variety of minerals are best to find the amount present of a different isotope of the same daughter element. For example, strontium-86 compared to strontium-87. In practice, it turns out that the ratio of different isotopes of the same element is very close to constant in different materials found in the same rocks and formation. As such, this ratio of one daughter isotope to another can then serve as a comparison baseline. The ratio of parent isotope to daughter isotope is plotted against this daughter-to-daughter isotope ratio, and an age of the rock can be determined by noting the difference, without making any assumptions at all about the initial quantities of the parent and daughter material. This also serves as an excellent check against contamination. In other radiometric dating techniques, assumptions about the initial conditions are reasonable based on direct experimental observation. For example, argon is an inert gas which is generally expelled when crystals form, so potassium-argon dating can safely assume zero argon in crystals. Similarly, zircon rejects lead as it crystallizes. Variations in relative abundance of carbon-14 in the atmosphere can be cross-checked with other techniques like dendrochronology, and so on and so on.
Two, you have to somehow calculate the original amount of the daughter isotope.
Again, this is the strength of the isochron method generally used. It requires no knowledge of the original amount of the daughter isotope.
There are little detective forensic ways, but no truly scientific method, rigorous ways.
What's the difference between forensic ways and scientific ways? Are you saying forensics isn't science? Inference and deduction can be equally reliable to direct observation to an extent that we're willing to convict citizens of crime based on the method's veracity. In fact, fingerprints, bullet striation, DNA, blood spatter, fire accelerants, and many other types of forensics are considered to be better evidence in court than eyewitness testimony, and much better than second-hand hearsay, which is what we have in the Book of Genesis.
They also have to assume that the rate at which, for example, uranium decays into lead has always been constant, but they've only been measuring the decay rates for 100 years.
It is true that measurement of decay rates has been happening for only 100 years or so. This is as long as we've known about radioactive decay, and in that time, no variations have been found. How many years of observation do you think one would need in order to start using these observations to make predictions, and feeling confident when those predictions are affirmed? 500? 1,000? In a creationist time frame, 100 years is almost 2% of the entire age of the universe. That said, nature does have its own time machine in the form of light from distant stars. Whether you think that light left the star billions of years ago or only thousands of years ago, it is showing us what the star was like much further in the past than 100 years. Astrophysical observations of the luminosity decays of distant supernovae, like nickel-56 to iron-56, strongly indicate that decay rates were the same then as they are now, extending our confidence that these rates have been consistent for the age of the stars themselves.
Pressure, magnetic fields, and heat can change the decay rates.
As a general rule, alpha and beta decay, the kind of decay used for most radiometric dating, is not, in any way, affected by even extreme changes in pressure, magnetic fields, or temperature. This has been affirmed over and over in published experiments with direct observation. A third type of decay, electron capture, also known as K-capture, which involves absorbing a particle rather than emitting particles, has been demonstrated to potentially slightly change under extreme pressure conditions, but by no more than 1%. Even so, of the flavors of radiometric dating, only potassium argon involves an electron capture process. A variance of less than 1% due to extreme conditions rarely found in nature is obviously not enough to explain the difference between 6,000 years and 4.3 billion years, particularly when most finds cross-reference multiple dating methods. I could find no confirmation of experimental data showing decay rate changes due to magnetic fields or heat, neither in peer-reviewed science publications, nor even in creation sources like Answers in Genesis or Institute for Creation Research. On these factors, Charles misspoke, is mistaken, or he knows of some data that even his creationist colleagues do not.
Radioactive lutetium decays 9 trillion times faster in the plasma state.
9 trillion? Charles is talking about something called bound state beta decay, a hypothesis proposed in 1947. Because protons in the nucleus and beta particles have opposite charges, they attract each other. So kinetic energy must be expended for the beta particle to escape. If the nucleus could be stripped of electrons, and thereby its charge, the beta particles might be able to escape much faster. Experiments to test this bound state beta decay hypothesis would have to wait until 1992, when dysprosium-163 was found to decay with holmium-163 with a half-life of just 47 days under bare nucleus conditions. Unfortunately, we can't compare this rate with normal conditions, as dysprosium-163 is normally stable and doesn't decay at all. More recently, an experiment demonstrated rhenium-187 decaying to osmium-187 with a 33-year half-life in bare nucleus conditions instead of the conventional 42 billion-year half-life. This is an amazing billion-fold increase. But even so, a billion is a much smaller number than 9 trillion that Charles threw out there.
And evolutionists, Big Bang theorists, believe the whole universe began in the plasma state.
Bare nucleus condition isn't synonymous with plasma state, and the role of plasma state in Big Bang cosmology is not settled. And to sustain this state requires heat levels that would melt the Earth instantly. But those quibbles aside, as we've learned, the radiometric clock doesn't start until a rock hardens. A theoretical hyper-fast decay rate in an ancient plasma state would have no influence on a rock now in solid state.
And one more, you have to assume the sample has been in a closed system the whole time.
With details depending on whether you're talking about physics, chemistry, thermodynamics, or another discipline. For the purposes here, a closed system would speak to a physical system where matter does not enter or leave. While few absolute closed systems exist in nature, when an igneous rock solidifies from magma, it approximates a closed system so closely that they produce consistent results across multiple radiometric dating methods within 1%. Of course, geochronologists are fully aware of the possibilities of contamination, and a good portion of their effort is in reducing the impact of such contamination on the results, including utilizing multiple samples for cross-reference. When ages from such samples fall within 3% of each other, it is extremely unlikely that the same contamination would occur in the same proportion in each sample. Some of the methods have other error checking opportunities, like uranium-lead dating, where two different isotopes of uranium, 238 and 235, decay to different isotopes of lead, 206 and 207. If the system has remained closed, then plotting the two ratios will fall on a known line called the Concordia. If they don't fall on the known line, there has been contamination. An absolute closed system is not a requirement or assumption. A close approximation to a closed system is something tested for.
Scientists who are well informed on this issue, PhDs in geology and physics.
Is this an attempt to appeal to authority? Charles may be aware of a handful of PhDs who doubt the veracity of radiometric dating, but certainly there is also an army of PhDs who would affirm it with equal vigor. What would we do in such a clash of PhDs? Scientific truth isn't determined by vote nor credentials. It's determined solely by the explanatory power and ability to make unique, accurate predictions about future data.
They say there's problems with every one of those assumptions.
By problems, do you mean the known limitations, parameters, potential pitfalls, useful circumstances, and techniques to minimize these issues for each of the assumptions? If so, then I would agree that not only are these so-called problems not only well known by PhD scientists, but they were also discovered and publicized by PhD scientists in geology, physics, or a related field. To date, no such problem has been discovered by a creation scientist, who have instead misrepresented the work of others in an effort to cast doubt on methods that are demonstrably and consistently reliable when applied appropriately.
Next on the Science of Genesis Paradise Lost. Part 9, Dem Soft Bones. Tap the subscribe button and the bell icon so you don't miss it. If you'd like to support the work of Paulogia, please consider becoming a patron at the link in the description. Thanks for watching.